Good evening, guys. Last stream of the day. We are working on the filtering of the HBS data. Let me quickly first share the link for today's stream. Getting back slowly to the old pace I had before the travel. Okay. Hope you guys are doing well. Let me open up the live chat. So the filtering from the previous stream is still in progress. While that is happening, I want to check out our toxicity lists and how to integrate the fuzzy deduplication as well. So let me think what makes the most sense to do next. Fuzzy dedupe, toxicity, LID, all of this is needed. Let's start with some of these. But before that, I want to just quickly see why is the ratio set to 9 here. Let me see what the paper says about the ratio. Okay, there's a ton of matches here. Maybe if you could do it like this. Okay, exceeded numbers ratio, exceeded punctuation ratio. This is for monolingual pipeline. This is for the laser. I'm looking for the ratio in the length, actually, not this one. Let me see here. The length-based filtering identifies sentences are not within provided maximum and minimum length ratios. For mined and back translated data, we filter out sentences with length ratios above 9. Okay. For back translations, we additionally filter out sentences of length below 15. Huh. Okay, I think that's everything they mentioned in the paper. I definitely think we need to change the number here. So it shouldn't be 9, it should be something more like 2 or 3 max. So I think this should be something like this. Because all of these languages are fairly similar size, similar lengths. Let me just see quickly how this one is going to be used. So filter config, find the group filter config, and then length filter. Okay, and the ratio is set here. Let's just see how it's used. Okay, filter line. Length ratio. If it's bigger, if the ratio between the source length and the target length is bigger than this, then we add it here. I doubt we'll ever hit this with the current setup of 9. Doesn't make much sense. So yeah, I'm definitely gonna create something a bit more conservative. Hi Andy, welcome to the stream. Okay, so back to the example. YAML, I think even 2 is probably an overkill. Like it shouldn't be more than like 1.5 or 1.4. Maybe 1.5 makes sense. Awesome. Thanks, man. Appreciate your kind words. So for min length, if we just set 5, we will be accepting single word translations, which probably makes sense. Let's leave it at this for now. And let's focus on the other 3 filters here. So LID, toxicity, and fuzzy dedupe. Let's see for the toxicity and for fuzzy. So for toxicity, if we go here, toxicity filter. Okay, I've set it up here. The path is set like this. This one does not exist. Max difference, if the difference is 2, then we filter out. No worries. Thanks a lot. So under fairsec root, looking for, so fairsec NLLB 200. Let me see, where can I find that? Aha, this is Stopes. So I'm in the wrong repo. So under here, under the root of the fairsec code base, I need to find the toxicity lists. Just collapse this. Collapse all of this. Let me try and find if I didn't delete it already. Maybe I did. Huh. Yeah, apparently we don't have this anymore. So let me just download it again. Toxicity. I know I've added a comment somewhere in the README. More likely here. Where did I mention that? I know I have instructions somewhere for downloading this data set. Let's just try. I think we can just do something like this: toxicity list meta or NLLB. Okay, here it is. Found it. And let's save it here. Back to FairSec. And let's find that toxicity list. Let me open up the folder here, unzip this one, extract here. And now we're interested in Croatian. Let's find Croatian. HRV, this one. Extract. Password protected. Password protection is this. And then we're looking for Bosnian. So BOS, this one as well. And finally Serbian, SRP. Here is the SRP. Okay. Now let me just open it up. And I'll have to remove it from the screen just because YouTube will potentially cause me issues if I display the toxic words or something, I don't know. So just better to remove it for the time being. Okay, Bosnian. Let me just skim through the words. Okay, it looks fairly detailed. Fun. Oh my god. Okay. Bosnian looking good. Let me see. Croatian. Similar. And Serbian Cyrillic. Not that good. I might be able to improve the Cyrillic. List, but for now let's just leave it as it is. It doesn't have to be perfect on the first iteration. Okay. With that, I think we can enable the toxicity filter. Let's go back to Stopes. Let's open up the filter file. Awesome, man. This sounds good, man. Catch you later. Max toxicity difference. Thanks, man. See you later. Okay, config is here, and then let me see how this one is used. Okay, toxicity difference. Aha, got it. So if the difference is not none, then we count. Okay, if the difference is bigger than this, then we add, and okay, we return the counts here is incremented, and then return none, which means we filter out this line. Currently set to 2. How exactly is this computed again? Let me just see. So we ask what's the toxicity count by passing in the sentence. Is the sentence, okay, sentence is just passed as a simple string, and then toxicity count does what? Toxicity list, and then we call toxicity count. Replace Unicode, then we tokenize it, and then we go through all of the words in the toxicity list, and if it's present, we add it up. Okay, fair enough. Replace Unicode punctuation. Okay, that's this mapping here. And then we call tokenize, which strips, replaces, split on punctuation, symbols, and hand characters, collapse multiple spaces. Okay. Makes sense. I think we need to just modify the config for the toxicity filter. Go back to the example. Toxicity filter, should this just be a boolean or what? Let me see what exactly we need to specify there. Whoops. So we instantiated toxicity filter, and we pass in the languages. Okay, let me quickly see whether that makes sense. We need to pass in the lang. Let's see. Toxicity filter. So we have to pass what? Source lang and target lang. Max toxicity difference and the path. Let me just add a breakpoint here to make sure it makes sense once we start using it. Still not clear how I have to set up the config. Let me just open it on the side here instead. Okay, instantiate the toxicity filter. Dedupe filter. Not clear what's going on. Target language, source language. Okay, those are specified already. But what do I need to specify in here to instantiate it? Let's see. Maybe like this. Not sure exactly, but let's see. Okay. Let's see whether this will work. So that's the toxicity part. And then we also want to add fuzzy deduplication. And LID filtering. Okay, let's start with fuzzy deduplication. So I have some initial code for fuzzy, but we need to integrate it inside of here. So ideally, I will create another filter and call it fuzzy filter, and then just implement the logic in there. Probably makes the most sense. Let's see how we can do that. Filter group. Let's find some implementation like length filter or something, or toxicity filter. So here we need to implement a constructor and a filter line function. Basically, this one is going to be called by the filtering pipeline. I'm gonna add dedupe filter. Let's also add like a fuzzy dedupe filter. Okay, looks good. And now let's grab the logic that I previously implemented here. Temporary fuzzy, this is it. And we need to do something along these lines. So LSH insert. Let me just grab all of this. And one more line, which looks like this. Okay. This is a good start. So, what do we do here? We have to beforehand prepare the fuzzy dedupe filter. The logic here is a bit different. We can't incrementally do this, I think. So, let's see. We also need to import from data sketch. Something like this. And then, so let's specify the number of permutations to I don't know, maybe like 100 for now, and then we can say like we want 25 or something, or maybe 10. This is something that we'll have to experiment with. Okay. So we have to pass all the lines when we're constructing this one. LSH, and then later we can query and ask okay, how can we do this? We first insert, so we're creating the LSH, and later we query. I wonder when we get the let's imagine we have like 3 fuzzy duplicates and we hit the first line. We hit the first candidate, and if we decide to have a heuristic that when we hit the first candidate we filter out the subsequent ones, will that work? If then later we hit the second candidate and we see that it's second, we can just ignore and do nothing. How can we do that? Or we can always filter all of the candidates except for the last one. So just leave the last one. I think that might make sense as a heuristic here. So always filter out if the length of result is bigger than 1. Okay, I think this will work. We return none, some of them. Okay, this logic will go in the actual filter line part of the code. So somewhere here, we're going to see how we're going to integrate it in a second. And this is the construction. I'm only going to focus on the pair duplication, so we can ignore all of this. And I think we also don't need this. So we can just do something like self LSH equals this. And then what we need to pass in is the source lines and target lines. And then we need to go through the, we can maybe just remove this. And then remove total because there was the argument for the TQDM. So we end up with something like this. Target lines, source lines, source line, target line. We strip. And then for each of the words, we update. Okay, this is actually not the right logic. We want to do, this is where the shingling comes into the picture. I think we might be able to just reuse the code we've seen in Pinecone today, the Pinecone blog, and then we just do self LSH insert. Okay. Let me find the Pinecone code. So we're looking for shingling. I think this is basically all we need to do. Build the shingles, and then build the vocab. Okay, yeah. So here is everything we need. So once we strip it up, we go and do something like this. So given the text, we can do something like single and then just pass in this, and k can be by default 5. Define this here. as an inline function. So we go through the source lines and target lines, we strip them, then we create a final line like this, we shingle that, and then get shingle set, and then this is going to be like shingle, and we code it, and that's it. Okay, this should work. And then given the line, we don't need none of this. So given the line, let's store this as well. So we're gonna store self this, and then we can use it here. And then given the line, we grab the source and the target, and then we want to shingle that again, so that means we'll have to reuse this one, and that means we have to just make it a independent function here. Looking good. Shingle and self LSH query. If the length of the result is this, and if we are let me see, what should be our logic here? If you're not the last candidate, just remove it. We just leave the last candidate. I think that might make sense. So if we have candidates, in that case, if we might need to pass in additional piece of information here, like something like this. Is filter line, let me see, the abstraction here. This is, we have to have this signature. I can't modify this. I can maybe prefix the line with the index. We can do some hacky way of getting this to work. Let me just think for a second. How can we get information about the I? So we get the line, we get the counts. Okay. What do we do with the counts here? This is what we want to do. And then return none under certain condition. So I'm gonna do a hack here. So I'm gonna infer the I by taking the line source and grabbing, let's say, grabbing the first 6 or like whatever, 8 characters, casting that into int, and then line source equals to this. And then once we have the line number, we can do something like if the result of -1 equals to the I. Exactly. I think this should work, guys. We're gonna test this, but I think it's fair enough. Okay. And now we need to see how we can add this one to the config. So, example, dedupe filter config. Okay, I'll have to just see how this is called. Just run it. It's gonna be easier than trying to dry analyze the code. Let me create another instance here. So we need to see for the fuzzy and for the toxicity how those are gonna be called. Train primary, dedupe, toxicity, filter. Okay, looking good. No, we need to change the output in order not to mess up the current filtering logic. So let's go here. Let's change the output directory such that hey Arnav. Hey man, what's up? Currently working on the Open NLLB project. Happy to fill you in as well offline. I didn't see your message immediately. If you're curious to contribute, let me know. I'm happy to fill you in. If you're still here. Okay. Yeah, 100%, man. By the way, check out the Open NLLB channel in my Discord. You'll see a ton of information there. There is the pinned messages here. You can check it out. And I'm happy to show you what I'm working on at the moment. By the way, just came back from China, so I'm barely looking at my eyes because of jet lag, but yeah, check it out. But in a couple of days, I'll be like brand new. Okay, where do I specify the output directory? I don't see that. Where is the output directory specified? Am I blind? Okay, I don't see anything specified here. Okay, let's just rerun this again. Load directions. Open this in the read mode. And then output directory. Where is this specified? Oh my god, okay, in the launch JSON. Let's create a TMP here and rerun. I'm gonna stop this. Rerun again. Hit F5. And HBS TMP, here it is. Okay, let's now see group config. Let's see how the toxicity filter and the dedupe filter are specified. Especially, let's start with toxicity filter. How do I... Load the datasets, load the length vectors, that's fine. And then we get here, direction. Go through the corpora. Okay, we grab the datasets. And then we submit here. Let's go. Okay. So laser config, nothing is specified there. Length filter, that looks good. And then LID is again none. Toxicity filter is specified. Okay. So I guess by the very fact of not specifying none, we get the default settings. I think that's what's happening here. So what I specified is in the example YAML, toxicity filter, we can just, if we don't add anything, then we use default. I think that's how it works. And let's see. Let's go to the constructor of the toxicity filter. You probably hit it right now. Okay, let's try and go here exactly. And we've passed in the default values. This failed because there is no such file or directory. Why are you expecting that to exist? File not found in the source toxicity list with open. Okay. So line 25, line 76. Line 25, open. 76. Okay. So source paths have been specified. Which is the case. English, yeah, for this one, let's just set it to none. So let's go here. Let's just set this to none. Let's set the difference here to 1. So again, go back to the example YAML. I'm going to split it right here and just specify this as 1 instead of 2. We don't need this because the default value works already. I'm not sure what's max toxicity. And I think this is it. This should now work. Let's go to filter. Let's stop this run. And let's retrigger it. So put the breakpoint here. Kick off the filtering pipeline again. Okay. How is max toxicity used exactly? Let me see for the... Okay, max toxicity is used in here. If the source toxicity list is not none, then we get the source toxicity. Aha, got it. And then if the max is not none and this one is bigger than the max, then we just filter it out. And same thing for the target sentence. Okay, I think we should allow even highly toxic language as long as it's accurate translation. So from that standpoint, I think it's fine to leave this as none, because when it's none, we are not using it. Okay, makes sense. So that is good. Source path, if it exists, then we append it. Okay, we should definitely unzip this one. So let's go back to fair.sec. Let me open up the NLLB 200 TWL, which is the toxicity word lists. Let me quickly open up this, find English. I'll have to grab the password here. Find English. Extract here. And we now have the English toxicity list. Go back to Stopes. So now we should be good. We should be good now. Okay, we have the right config now for the toxicity filter. This should work. And then we need to figure out how to introduce the fuzzy duplication. So I'm going to stop this run again and rerun yet again. Hit run. Okay. So let's now see if this works as expected. So this should be, okay, yes. We add this one and we create a list, and then we add this one as well, and then we create a list. That's it. That worked as a charm. Perfect. Now, how do we introduce yet another filter? We do that by by adding something like this here, and then we say fuzzy dedupe, and then we go to so parent to this config is a group filter config, which means we have to modify it. So I'll have to have a fuzzy config, which is going to be fuzzy dedupe filter config, like this, and we need to create this. So that's going to be a data class. And what we need to specify there is going to be, let me go back to the constructor. So for this one, we pass in dedupe pairs, which is a boolean, and then max source dedupe and max target dedupe. So here, instead, we have to pass in something like this. And we need to specify the pairs. So the target is going to be exactly filtering filters, the fuzzy dedupe filter. Will this be accessible? Let me see. I probably have to expose it here. Okay, import this and import fuzzy. Okay, now this is exposed. Now that it's exposed, we can set it as a target, and then we can have this be a list of strings and sync here. And we don't need the commas here, that's the syntax. And I think this is it. Okay. Unless you set it to none. Okay, I'm gonna just add it here. And I'm gonna set number of permutations to 100, which is the same as the default one. Okay, with this, we should now have a fuzzy filter. We do need to just modify things just a bit more, because this one requires all target and source lines to be present. Let's see, filters are used in here. So I think we'll have to add these two filters a bit later. Let me see. What makes the most sense? So the issue is we have to have all of the source and target lines present in the constructor for the fuzzy deduplication filter, as opposed to all of the other filters which don't need that information. what's the best strategy? The thing is, I have to be careful where I do that because we're looping here over corpus names for this particular direction. And then we just use the filters here. We need to construct them only once. Okay. I'm gonna do something like this. Let's extract information about the source and target sentences before the loop starts. So inputs is here, and then we go through the lines, and then the line contains both the target and the source. Okay. Okay. And then we just need to create a list up there and same for the target. Will this work? We go through the corpora. We open up the dataset with the corpus name. And then for the lines, we just append those. I think this will work. So we just do this above here. And now that we have those, we can pass them into the filter here. Exactly. Target lines and source lines. Nice. By doing that, we create the LSH, and then we can later just query. Guys, I think that's it. I'm gonna now stop the run again. Let me see how we're progressing with this. It doesn't seem we're yet done with the first filtering job. It takes a couple of hours. But yeah, let's just experiment with this logic here. So I've now added the toxicity and the fuzzy dedupe. Hopefully this now works without any crashes. Let's just verify that's the case by hitting run on the filtering pipeline yet again. Okay, there are some issues here. Aha. I think we have to do it like this. Or maybe we can just specify empty. Okay, let's go. What now? Mutable default list for field is not allowed. Let's just set none. Or yeah, I think we need to specify a list from typing. I think that's the issue. Let's go again. Non-optional cannot be constructed from none. Okay. Again, this needs to be optional. Let's just get it to work. Okay. Almost there. So we iterate through the data and we keep on appending. See what my memory, how my memory is handling this. 28 gigabyte of RAM going up. 30. I doubt we'll have the issue here. There's not that much data. But we are apparently still loading. Let me think. We have like 100 million sentences per direction. So let's say we have 300 million. 300m times some number. It's going to be a significant amount of memory. Off the top of my head, let me think, how much could we have? Well, let's see quickly what's the size of the data. It's still going up. We're over 42 gigabytes. So I might have miscalculated here. Let's just open up this. How big is this? Oh my god. 40 gigabytes. But we're not using all 5 directions. So I'm expecting less. But not much less. Maybe 30 something gigabytes. Let's see how it goes. And it's still rising up here, 53. And then once we start, this might explode memory wise. It's still going up. Yeah, this is gonna crash. I need to stop this before it crashes my other job, so I'm gonna just stop this one. And the memory is now back. So let's see what I can do instead here. Let's just test this with a single direction. Maybe with Serbian Cyrillic. And now let's rerun this. Okay, it's running. What else do I have as the next task? So we've added this, we've added this. We need LID as well. Language ID filtering. So that means we just need to keep the HBS languages plus the English and nothing else. Like we need to filter out German, Turkish, etc. And maybe add a couple other filters like dates and numbers for the mined data sets. At least we now know how to easily add a new filter. So we can add the about to. For the LID, they already have some support. Let's just see quickly. Let me recall quickly how that looks like. This is running. Let me see if it's still running. Yes, it is. How many lines have you loaded? Okay, almost there. Laser LID filter config. Let me see here. LED filter, model path. Okay, we load using the fast text. And then in the filtering stage, we call the predict. Okay, I might need to modify this a bit. Like I might need to create something like HBS LID filter and add a bit more heuristics to this. Until we train our own LID, we need heuristics. So that means I'm gonna copy paste this one. Do something like HBS LID filter. And then okay. So let's do a similar thing as what we've done with the fuzzy filter. So we have to go to init and we need to expose LID filter and HBS LID filter, and then go to configs and grab this one, create yet another one and call it HBS, and change the model path so that we're using the, let's see what exactly we want to use there. Versec under data, I did have the LID bin. This is the, I think this one is the open LID model and not the NLLB. Let me just see how we're using this one. Okay, here's the LID and here is the open LID. So at least on Flores, the open LID is better. So this one, but that does not translate necessarily to better results on the actual data that we'll be using it on, if that makes sense. Just a second, guys. Okay, guys. I got some healthy drink right here. Weird taste. Something failed because I probably have some typo or what. Aha. Source and target. Oh my god. That's because I mistyped it here. This should be target lines like this. Let me just make sure we're using the consistent. It should be target here. I just need to change that in here for the fuzzy. Let's call this target. Okay, and now this will work now. I'm gonna stop this, and just for the sake of testing, I'm gonna add a counter here. Okay, need even smaller, 5,000. So I was adding the new LID. And I just need to rename it to HBS LID filter config. Well, I actually don't need to do this. I just need to change the existing one. So that's actually good. I just need to modify this one directly inside of the config here. So if we open up the LID, instead of null, I'm gonna put something like target is actually HBS. And then model path should be, let's just try whatever for now. Let's just grab this one for now. Copy the path and put it in here. Okay, looks good. I think that's it. We now have all three filters. Let's kick off the run again. Again, unexpected something. Target lines, why are you complaining? Why exactly are you complaining? It should be target. That's why. Okay. Rerun. Okay. Here we are finally. Positive tube. We know these ones are gonna work. LID. LID worked as well, apparently, and toxicity as well. So then we are left with, once the constructors are over, we are left to just analyze filters one by one. I'm gonna put a breakpoint here. Let's see how this is gonna work. So we concatenate these, and then we grab the shingles. And we just add them here. Okay, this might be problematic because 6 is too small of a number. We need to see what's the length. How many digits do we have here? And use that accordingly. If that makes sense. Otherwise, I think this will just work. How many lines do we have? $5,000 only. Okay, for now this is gonna work, but let's add a to-do. Infer this number from source lines. Okay, we are already here. And the first filter is dedupe filter. Why is the length and dedupe? How come? I'm expecting to get, maybe wait. Let me just add the breakpoint here instead. Okay, I forgot to add for the fuzzy dedupe filter. We need to have this special thing going on. So if we detect that the filter is fuzzy dedupe, we need to add the line number. So that means we need to completely change this code. Enumerate. And then we'll just name this I. And then if the filter C class okay, so if the filter class name equals this, in that case we want to modify the line source such that we do something like this. We do I followed by line source, and I mean this is super hacky, but for now it's gonna work. So I'm expecting first eight characters. Okay, let's go back to the filter. So that means we need to do something like string and then zfill and then 8. Okay. Stop this. And rerun. I'm now waiting for launcher to connect. Interesting. Am I running the correct line? Okay. So I want to add to toxicity filter. Put the breakpoint here. Same for the LID filter. I want to put the breakpoint, I guess, here. And and fuzzy as well. So fuzzy, LID, toxicity. Go back here and run. Okay, the first one in line is the HBS LID filter. Does that make sense? Are we going in the right order? So we have the laser, the length, the LID is the first, then goes toxicity, then goes fuzzy. That's the order of the filters that we'll be hitting. So let's see, for the LID, we did load the right model, and then we do predict. So it gives us the languages and the probabilities. Okay, most of these are super small numbers because they are raised to the power of minus 0.05. Get for the source language the probability. Predict for that one as well. Let me quickly see what do we do in FairSec. In FairSec, I'm also using the LID models. Model predict. I have a bit different logic there. This is more elegant. After prediction, okay, nice. If source threshold exists and source language is not excluded, then we see whether, if you're smaller, then we filter you out. Fair enough. Okay, this is the logic that we have to change. We have to add certain heuristics here. Next up, toxicity filter. We count the number of here, and then same thing here, and then we compute the difference, and if difference is bigger than 1, so if difference, well, if difference is, okay, if it's bigger than 1, I'm gonna just see when do we hit this line, if ever. And finally, we are now ready to modify this one and then hit run, and we extract and parse this as 0, and then we modify this one. Aha, we lost the first letter. Okay, guys, I have an alarm for a meeting, so I'll have to jump. But this is good work for tonight. I think most of this works properly. Let me just see. Even though this is kind of, I'm gonna add a to-do here. And then we just update here, and then we find the result, and only if it's bigger than 1 do we enter here. I think this is gonna work. With some small polishing, this should work. Okay guys, that's a wrap for today. First day of working on the project after the China trip. and we're gonna continue tomorrow. So catch you tomorrow around 10:30 a.m. Central European Time. Cheers, guys. Bye-bye. Have a good evening, good day, and good morning, wherever you are.